okay. I've been
all right. So, does anyone know what a translation is?
No.
Yeah.
Okay, it's actually pretty easy. It's more of like a slide. Okay. When I did this, I bet all of you knew what I was like when I was kind of teasing Olivia. I went like this with my hand. Hasn't my hand been reflected like that? Right. If I want to do a translation, I can't do this at all because that would be like rotating it, right? I can't do this or that'd be a reflection. A translation is literally just sliding it. Actually, I think of those screensavers, like on a TV or on like a computer. You hope it goes in the corner.
Oh, yeah.
You know what I'm talking about? That's a translation. It's just kind of sliding around, slide to the left, slide to the right. It can't. Well, I guess it could do two opposites too. So we'll talk about translating figures, some rules for them, and what a rigid motion is. Do we want to work with a partner and do something?
Yeah.
Ooh, I heard yeses first. So first,
Emma, why not?
I'm going to give you guys 2 minutes to work on this. But first, let's get through a couple notation things first. Triangle DEF is translated to become triangle. This is read D prime, E prime, F prime. All that's telling you is E prime, I'm the new E. D prime, I'm the new D. F prime, I'm the new F. All right. So it's like DEF was the original. D prime, E prime, F prime is it's going to be called the image. All right. So let's, with your partner, just next to you, we're not going to move around, just your table partners here. How would you define a translation, one, and then what do you notice about the side lengths and angle measures? Okay, between the original DEF and the new one, D prime, E prime, F prime. Maybe even a minute and a half. We don't need 2 minutes. Ready, set, go.
You're right. It's slow. Yeah. Unless that's how you just define it. So if it goes I have no idea. Yeah. And then just the names of the different things.
All right, let's do letter A. Preston, what'd you get for A? How would you define a translation?
You just said that it was like the same exact thing. There's nothing that they would.
Well, okay, so, but how would you define it? Like, a translation is
It moves like up and down and like that.
good, a movement, and then you might have to so, the critical little person who's going to try to be arguing with you about everything would say, well, but what if it slides this way and it changes size? What would you say to them? Can it change size? No. Could it change shape? No. So a translation might be anybody else have other words? That's good. So yeah, it's a slide, a movement.
It stays the same.
Stays the same.
As it slides.
Okay, good. Anybody else add something to it?
The lengths and angle measures are congruent.
Good, so we're on to B now. Yeah, and these are kind of intertwined. No, they're kind of intertwined. Like how are you going to describe it unless you start talking about things that can't change with it, right? So that's fine. The angle measurements and the side lengths stay the same. Do you guys agree with that? So, we kind of alluded to it. It can't change size as it slides. It has to stay the same. So translations are really pretty straightforward. Now, a new term, I guess I'm not sure if this is new to you or not. Have you heard of the word vector before? No. Vector! Now you have. Anybody remember his tagline? Committing crime. Do you remember that? Because this will help you remember it.
With something in magnitude. Precision in magnitude.
Direction.
Yeah.
That's close, Jack. Committed crime. I think he says it like with direction and magnitude. Oh yeah. Oh, we should have pulled up the clip.
Do it.
We will in a little bit. All right. So it's kind of funny, but yet it's easy. It helps you remember because a vector is a quantity that has both direction and magnitude or size. So don't overcomplicate that. Do you know what the word direction means? Oh yeah, go towards that. Like you point to something and you say, go that way. Okay, direction. What's magnitude though? Do you know? Direction is which way you're going. Magnitude is
Would it be how far?
how far? Good. So magnitude, or isn't magnitude? You think of a measurement. When I think of magnitude, I think of like an earthquake. The magnitude of an earthquake. Have you heard that before? Like the measurement of it. Magnitude is a measurement. In this case, we would say, go that direction 10 feet. Okay. And go that direction 10 feet. So a vector has direction and magnitude. Oh yeah. So on a graph, we're going to have a vector that might look like that. And the easy thing about looking at a vector is it tells you which direction it's going. It has an arrow. And the length of the vector is the magnitude. It's how far you're supposed to translate whatever shape you're dealing with. Let me say it again. The vector tells you the direction and distance to translate. So if I were to take point P and translate it or create a vector called PQ, then isn't this the direction of PQ and the length? You wouldn't say 5 units, right? 3 units up. You'd actually have to find the length of that segment. If you're not told it, you'd have to find the length. So 2 things about a vector. I guess I'm getting ahead of myself. 2 things about a vector. If you're given it with these pointy brackets like this, that is not a point on the graph. Hear me very clearly. Someone's going to ask it. A vector can be written in what's called component form. It has pointy brackets. This is a command. Are you ready? It's not saying plot a point. It's saying move 5 units to the, well, it's a positive 5, right? And move up 3. Okay? So what if you have a triangle and you're told to translate it using this vector? Let's call the triangle ABC. You'd start at A and move 5 units to the right and 3 units up and plot A prime. That's the new A. And then the next letter is B. Okay, here's B. Take B, move it 5 units to the right and 3 units up, and now we call it B prime. Very good. And then C, 5 units to the right, 3 units up, C prime. Now that's component form. If you were to find the length of that vector, you might actually have to use the distance formula or be told it. Ellen.
This is kind of like rise and run.
Very much. Yeah. This is like the components of rise and run. But we're not writing like a slope. We're writing it in component form as a vector. Now you can't unhear it, can you? Every time we say it. How many of you have never seen the Despicable Me clip where vectors in it? Oh, you're missing out. We're going to have to show you a little bit. All right. So I kind of skipped over it. A couple things. The vector, this one's vector is named PQ. And that's it's kind of grainy, kind of tough to see. Can you see how that's written? It's not line PQ. It's got like a half arrow. I'm going to rewrite it since it's kind of tough to see. It's like the top half of an arrow. So it's called vector PQ. We're not going to call it line PQ. All right. Oh, I didn't cover it up. And you can't see it. There we go. All right. Name the vector. Let's go with Kate. What do you think? Vector. You serious?
What?
You said JK? Oh, gotcha. See, this is what happens when I don't get a lot of sleep. I apologize. I'm a jerk. You good, Caden?
Yeah, I'm good.
Hey, if you said I'm a jerk all the time, back off. Press. Just kidding. All right. Component form. You guys have this one on your graph?
Yeah.
Can you guys count it on the graph pretty easily? So you pick the point J. Now, if I were a student, I'd be asking, I think it's obvious in this one. Are you going to count from J to K or K to J? J to K, right? It's direction. It gives you direction. Has a terminal point, J, and an arrow going through K. So the horizontal component, you have to decide, am I moving right and up, or am I moving left and down, or left and up, or left? What combination? Well, let's go with Paige. What's my horizontal component?
Right 3.
Right 3, so we're going to put plus just a 3, positive 3. Good. And Alana, what'd you get for the vertical component?
4.
1, 2, 3, 4. Good. 3, 4 is its component form. So the name, JK. Component form, 3, 4. Easy stuff. Next. Now this is not just for vectors. A transformation, this is going to be an all chapter kind of thing. A transformation is the umbrella name that a translation falls under, a reflection falls under, a rotation falls under. In general, it's called transformations. Okay? So a transformation is a function that moves or changes a figure in some way to produce a new figure called an image. So image is the new figure. Pre-image is the original. That kind of makes sense. Pre means before, right? So image is the new one. Pre-image is the original one. So we're going to be transforming triangles, rectangles, lines. You can even translate a point. So in this picture right here, can you see what's happening? They kind of color coded it for us. Can you see that it started off as segment PQ? How can I tell that's the original? What's that again? There's no dash. Good. This one has the primes, right? Prime, image, new. No prime, pre-image, original. So they're taking segment PQ and they're translating it to P prime, Q prime. Now, when Paige told us the horizontal component and Alana told us the vertical component, didn't we add, no, we just counted it because it was a graph. Didn't we just add 3 to the x's and add 4 to the y's, right? So if I give you this point and I told you to translate it using a component form 3, 4, whatever this x value is here, you'd add 3 to it. Whatever this x value is, you'd add 3 to it. Agree? And whatever the y value is, you'd add 4 to it. Whatever this y value is, you'd add 4 to it. And that's where you end up. So when they say x1 plus a and y1 plus b, a was the x movement, b was the y movement. Make sense? So this is using the component vector A, B. You would add A to the x's and add B to the y's, and that's where you end up. And they get into some stuff here. It's kind of like, well, yeah, like Ella had a great insight about the slopes. And so aren't the components kind of like a slope? And so aren't P to P prime and Q to Q prime, aren't they going to be parallel? Because they're both moving 3 over and 4 up. That makes sense. They have the same slope. All right, let's do some on a graph. This is actually pretty easy. So the vertices of triangle ABC are 0, 3, 2, 4, 1, 0. We're going to graph those first. Make sure you're labeling them. Some of us kind of get in bad habits of not labeling the points. 0, 3 is right here. That's A. B, oops. Let's slide this over. 0, 3. B is 2, 1, 2, 3, 4. And C is 1, 0. Just be careful when you're graphing. Some people are graphing points incorrectly and it kind of messes you up from the get-go. The vertices of triangle ABC are A, B, and C. We graph those. Translate triangle ABC using the vector 5, -1. Bryce, what does that 5 mean? Take the points, move them right. 5. Now, if there's no graph, could you guys do this? If there wasn't a graph. What would you do to A? Which value would you change, the x or the y, Olivia?
X and add 5.
Add 5. So we're now going to be at a x value of 5, but don't stop there. The y value, Levi, what does that -1 tell us?
That it's gonna go to 2 instead of 3.
Yeah, and in general, we're going to move everything down 1. Good. So right 5, down 1. So right 1, 2, 3, 4, 5, down 1. And that point was from A. It's now called A prime. So A prime is at, what's its point? Careful. 5, 2. Don't just count. Don't just, like, yeah, I could go over 1, 2, 3, 4, 5, and up 2. Yeah, I know that. But use what A was. A was 0, 3. It moved right 5. Now it's at 5. Moved down 1. Now it's at 2. B prime. Well, B was at 2, 4. I move right 1, 2, 3, 4, 5. Down 1. That's B prime. B prime is now at, it was at 2, now it's at 7. It was at 4, now it's at 3. C moves right 1, 2, 3, 4, 5, down 1. C prime. And I'm going to graph the new triangle, A prime, B prime, C prime. So C is now at C prime, which is 6, -1. Something you should give the eyeball test is, does it look like the same shape? If it changed shape, you graphed something wrong. Okay? If something looks off, you graphed it wrong, or you translated incorrectly. Pretty easy, right? You like this stuff better. Well, some of you. Okay, now we're going to write a rule for the translation. Let's write it in words first and then as a vector. Why don't you guys try it first? Think of a rule in your head. Is this one on your paper?
Yeah.
All right. So PQR, triangle PQR. I'm going to write a rule to translate it into P prime, Q prime, R prime. Josh, what's your rule in words? Move.
Left forward up 1.
Good. And in component form?
-4 for that one, and then 1.
-4, 1. Good. And then obviously the main thing to catch there is that you're seeing where the original P is, and then that P prime is the new one. That gives you the direction. Otherwise, you probably had +4, -1. Right? That'd be the opposite. That would not be correct. Make sense? Graph the quadrilateral ABCD and its image after the translation X, Y. Now, okay, we have some terms and symbols to talk through. If it tells you it's quadrilateral ABCD, that's the original. And what's another name for the original? The pre-image. Good. The pre-image. And its image, which is going to be A prime, B prime, C prime, D prime. After the translation, X, comma, Y, there's some terms here. And at the end of course test that you guys are going to take in, I think April, late April typically, this symbol right here, it means like transforms into or becomes, okay? So XY gets transformed into X plus 3, Y minus 1. Don't get confused. If you're adding 3 to X, doesn't that tell you the vector's horizontal component? What's the vector's horizontal component? 3. And if it tells you to take 1 away from the previous Y, then the vertical component is -1. Does that make sense to you guys? So that arrow is like transformed into. I've also seen that end of course test say maps onto. It gets mapped onto. So XY gets mapped onto X plus 3, Y minus 1. Those are all synonymous. Okay? Transformed into, mapped onto, translated, tally.
When you write the vector, do you have to use those
Pointy brackets,
Yeah.
pointy. What else would you want to do?
use parentheses?
What would parentheses mean?
A point.
A point. Yeah. A vector has, I'll spare you, direction and magnitude. Okay. So it's not just a singular point. It's telling you to move this many units left or right and this many units up or down. All right. -1, 2 is A. -1, 2. -1, 1, 2, 3, 4, 5 is B. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6 is C. And 1, 2, 3, 4. 1, 2 is D. Oops, I did something wrong. Hold on a second. -1, 2. -1, 5. Oh, no, it just said quadrilateral. I missed. I read quadrilateral in my head. I was thinking it said rectangle. Okay. You guys see it does not have to be a rectangle parallelogram, anything, right? Just 4 sides. All right. There is our quadrilateral. And that's the pre-image. Let's read the directions. Graph, okay, and its image after the translation. So we're just going to graph this. So A prime, B prime, C prime, and D prime. All right, this tells us right 3, down 1. If I start at -1, 2, and I move right 3, now I'm at an x value of? Guys, if I was at -1 for an x, and now I moved right 3, I'm at 2, and my y value is 2, and I moved down 1, now I'm at? So 2, 1 is my A prime. B prime, well, B was at an x value of -1, now it's at? It was at -1, now it's at? 2. It was at a y value of 5, now it's at? 4. 2, 1, 2, 3, 4. Okay, I can tell, I know your comfort zone would just be to go to each point and move right 1, 2, 3, and down 1 and put a point and not even think about the numbers. Okay? That's fine if it's a quiz or test question. We need to challenge ourselves a little bit to understand what the components are doing to the x and y as well. Okay? I know you can count over and down. Let's also think about what it's doing to the x's and y's to get our final point, in case it's not on the graph. Okay? C. C was at 4, 6. If I move right 3, now I'm at?
7.
Move down 1, now I'm at?
5.
7, 5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. All right, D was at 4, now it's at? D was at 2, now it's at? 7, 1. And that's D prime. There's our, what's that name of the new shape? There's our image. Very good. Image. The black one was the pre-image. The red one is the image. They will use those words in the end of course test as well, so we need to get used to it. All right, rigid motion. I think this is in your guided notes. A rigid motion is a transformation that preserves. What does preserve mean? Preserves length and angle measure. Preserves. What's a good synonym for preserves? A rigid motion is a transformation that preserves length and angle measure. We've heard the word preserve before, haven't we? What's a preserve in our daily lives? Okay.
Something like this.
Keeps the same. I like that. Yeah. Like preservatives in food help keep it the same for longer, right? Not to spoil. Okay. A wildlife preserve tries to keep it in nature, keep it natural. Okay. If we're going to preserve length and angle measure, it's going to keep the length, keep the angle measure. It's not going to change the size. So, is a translation a rigid motion? Does a translation keep the length of the figure and its angle measures? Or does it change them? Keeps them. Everybody agree? So a rigid motion is a transformation that preserves length and angle measure. So a translation is a rigid motion. Is a reflection, the Olivia reflection, is it a rigid motion?
No.
Is this a rigid motion with my hand? I sure hope so, or else it would really hurt. My hand would be changing sizes right now, wouldn't it?
Mm-hmm.
Didn't I just, my hand is a reflection? Did I change the size of my hand or the angle measures of anything on my hand? No. So is a reflection a rigid motion? Yes. Is a rotation a rigid motion? Rotation. So these are going to be our rigid motions. When two or more transformations are combined, what if I said translate and reflect? Is the two combined going to be a rigid motion? When two or more transformations are combined, the result is it's called a composition of transformations, and the composition is still a rigid motion. Don't get confused by that. If a translation didn't change length or angles, and a reflection didn't change length or angles, the combination of the two is not going to change length or angles within that shape, within that quadrilateral or triangle or whatever it is. Is this making sense? All right, last one for today. We're going to graph RS and its image after the composition. So this one, we're not doing a translation and a reflection. We're just going to do two translations. Okay? Two translations. Very important that you label these accurately. Is RS a vector? No. What do we call our RS?
Segment.
A segment. Very good. RS is a segment. So just because we learned about vectors doesn't mean everything is a vector now. Okay. RS is a segment. And it tells us the translation. Now, I'm not going to ask you to write this right here with a vector in its component form. Okay. You could. It would be 40 brackets, 5, comma, -2, wouldn't it? Okay. But we're just going to use the rule to find our new point. Okay. So here we go. I'm going to start it. I'm going to do S first. Nope, I lied. I'm going to do R first. R, then S. R, I'm going to take -8, and it tells me to move +5. Right? 5. Agree? Okay. So ready? If I'm at -8 and I move right 5, now I'm at good. But don't stay there and don't even put a point there. Why not? Because the next rigid motion tells us to move. Careful, not with the up and down yet.
To the left 4.
Left 4. So watch what we're doing. Ready? This first rigid motion tells us to move right 5. Then the second one tells us to move left 4. These are two transformations. These are two translations. So where do we end up? Well, if I move right 1, 2, 3, 4, 5, and then I move left 1, 2, 3, 4, I'm actually right there, aren't I? These are two translations. The first one told us to move right 5, and then left 4. My R prime is now at -7. I'm not going to write the Y value yet. This green point is just a placeholder. I'm sorry, I should have been more clear about this. I meant to explain this first. Okay? I did the X's first. I shouldn't have put a point there. Because what does this tell us to do with the Y value? First one says move down 2. And the second one says move down 2 more. Do you understand that? I should not have put a point here. So I have my X value of R prime. I need to find my Y value. Okay, well, I was at a y value of 5. The first translation tells me to move down 2. If I was at 5, now I'm at, I was at a height of 5, now I'm at positive 3. It's okay. And then the second one tells me to move down 2 more. Now I'm at a height of 1. So I moved right 5, left 4. I go down 2 and down 2 more. This is the point I meant to put. I shouldn't have put a green point. It's kind of like a placeholder. I put the green point as to where my x value is, but then I had to move down 2 and down 2 more. So this is where I end up with that combination of translations. -7, 1. Let's do the s prime. Let's do the x's first. Here's s prime. I'm at an x value of -6. The first one says to move right 5. So 1, 2, 3, 4, 5. But then I have to move left 1, 2, 3, 4. Does everybody agree this is going to be the x value right here? I haven't moved up or down yet, but that's going to be the x value right here of my s prime. I still have to do the up and down. I was at 8. If I do the first translation, now I'm at a height of 8. I move down 2. Now I'm at, and then it tells me to move down 2 more. Mr. Park. So s prime is at -1, 2, 3, 4, 5. Up 1, 2, 3, 4. -5, 4. Does anybody see another way you could do this? Paige.
You could combine like the 5 minus 4, like that 1, and then -2 minus -2, which is -4.
You see what she did? She added these and added those. That's another way. Here's another option. Can I do the first one? I move right 5, 1, 2, 3, 4, 5, down 2, and I could call that s prime. And then I do the next one. I move left 4 and down 2, and I call that s double prime. And I could do like a step between the two. Okay, I could do one translation and then put a point, and then put the next translation, and then that's my final one. That's another option. I'm flexible with how you do it. All right, there's our homework for tonight. Try not to get lost in translation. Oh, we want to do vector. If you stay for second period, you get bonus content.